Greetings to all HOD, teachers and external. Today I am going to represent you the sales prediction modeling using machine learning. I have done this as an intern in Hitachi Consulting and they have not allowed me to share code as it is a breach of confidentiality, but they have allowed me to show what I have learned, what work I have done and how I have done through written format, and through this video also I will illustrate you the whole demonstration of the project with conclusion. Thank you.
Hello, good afternoon, everyone. I'm Omar. Whatever work I have done in Hitachi Consulting as an intern from December 2nd till 22nd of May, and I have been working on a project known as sales prediction, where I am making models for my project. And as I go forward, I shall explain each and everything to you. First, coming to the problem statement. What the project is all about. Here in Hitachi, I am the part of sales enablement team. The team takes part of the sales department of the company, and my role is to check whether the number of projects they have done over the years is a win or loss, or it went for no sale. So the projects are labeled as open, that has to be predicted, and rest are the values are given. Now the I have predict two things over here. One is the status code and the other one is the reason behind the win or loss. Now the constant sum of them which have been told to me is to keep the accuracy minimum of 60%, and the error factor has to be as minimum as possible. Now going to next to the various techniques that was taken by me to come across this analysis. As I went for the first day, I was not that much into the sales and finance part of the company. So I have to do a lot of research, and therefore I went for stock market analysis, HR analysis, how the product predictions are done in Hitachi. All these things are taken into consideration. Then the objectives that were followed in order to complete these projects are understanding of the data, where we have to check the uniqueness of the element, the cardinality check, where we check that how many times a particular column has values, followed by the missing values that has been filled up. Then I separated data on the basis of training set and test set and validation set, where the first part, train and validate, will help us to predict the values, and then we run it on the test to get the final result. We have to understand the various types of algorithms, and I came across the best algorithm in the process, and also generate a report of accuracy and error analysis, followed by choosing the I have made a Python dashboard which will help the company to predict the data, and at the end I have got an API call through which all these were connected together. Now the main question comes, where I could get the motivation to do this project. So coming to the motivation part, as you can see here, the company is going to under a merger, where it's merging with the Hitachi Consulting and Hitachi Vantara the time I joined. So this project was playing a crucial role to analyze what are the projects done by Hitachi Consulting and how it will go forward and merge with Hitachi Vantara, and his performance can excel since it's a consulting company and Vantara is a product-based company. So this motivated me. Plus, there are some parts which sales enablement team, which I was working with, they haven't come across. Some data analysis, some data visualizations. These things were prompted by me, and this was shown as output. Now, going for the understanding of how I coded the whole thing. So first when I went for checking the cardinality check for the data set. What are the unique elements, everything. Here data set, the data is here. Then I found the values, which are the values present, followed by the rows. These are the rows of the data set, and And then the unique elements in each, how many unique elements are there in each row. After doing that, I found the dates are not continuous, they're changing, and the values are can't be trusted because some of the values get corrupted over time. So after analyzing this, I found I purified the data, I dropped the columns. Here you can see I have dropped these columns from the rows because they are not they are having missing values and can't be predicted for at first. And thus I purified how I started with the data analysis. Then I went for making the model for data visualization. Here is the modeling how I take the data, then purified it, moves the make it all into lower cases, moving the white spaces to a strip, replacing special characters. After doing that, I started plotting. Here you can see region wise, every region, how the data started becoming better and better at analysis. Here every year we can see how much of the projects has been taken up and which region is having how much a percentage. Then going forward, here you can see the several sales stages that it's a winning stage or a losing stage have been predicted with the help of your relationship, like how the data has been divided. Then going forward, analyzing, here you can see the status code table with the relation enterprise, and here X represents loss, O represents no sell, and the square represents the number of projects that has been successfully won. You see 2018 has been good, but 19 has been more successful. Then comes your 2020, but since the data for the next few years is very less, it can't be tell where they mostly win or loss. That's why most of them will be predicted no sell. And as we go forward, we can see the data distribution of the projects taken by the company in various years and how it has been divided. Here 0 represents the Americas, then here one represents the EMA. Like that it represents all the regions, and the amount of global amount of money was expenditure on each of them for the particular projects. It was shown that maximum expenditure is spent by America, where very less by Southeast and other countries. So now we go forward. So the different geography analysis, I change here everything to numbers for the data as in your character type. So I change it to numbers for better your classification and clarification. Here again I represent the columns, and here you can say how I did data analysis of various regions, how they are winning and how much expenditure has been spent. If you see the number of losses in this one, the blue line represents losses, the orange represents a no sell, and the one is represented by green. So you can see that a large amount of money has been done to drift the third and uh, fourth year of 4 stages of sales stage name, whereas their expectations of winning has been quite low compared to stage 5, stage 6. These projects have been successfully delivered. Now going forward and understanding that thing for every client, it has been seen that the most amount of revenue has been kept on prospects, and competitors are also affecting the company. And you can see the revenue is uh, not divided equally. Newcomers are also contributing, and this is how we can see a large amount of winning is there in the prospect, and is a proportionally everything is affected. And as we go forward, we see the relationship and status code how they are getting affected, like with the like it's a new partner or is a customer or it's a competitor is clearly shown. And this one it shows a status code, win, loss, or it's a no sale on the manager status code. We see that most of them are no sale or loss, and win is very less. And this is the data representation. Then we verify the data, and here we took the geography region and country code, and this shows that the data is very vastly divided and not uniformly kept. Therefore, the prediction is not uniform. And one more thing, the region represents the area where the project started. Geography represents the region where the data and the project was from, and the country code decides where the project is going to be situated. So there's a lot of data analysis at the back end going on in order to come across this data. And going forward, I'll show you that how I use Python analysis to make more predictions and more data visualizations. Here you can see that now I run a Python code, and again I purify the data, make it ready, and I show the region wise how regions are affected, followed by relationships. And now we go for back to our PPT. Yeah, now since we have discussed what are the steps I followed, I go for next to understand what are the algorithms I have followed. The algorithms I took into consideration was SVM, naive Bayes, decision tree, random forest, and gradient boosting. And the best came out to be random forest. Why? Because it is 91% accuracy and very error factor is very less, and it helped in more in a proper data situation the data for the analysis, because it uses decision tree inside it, and it has resilient to overfitting. That means it's not overfits data. And the stages that has been followed for the implementations have been clearly shown over here. Missing value imputation, then the feature engineering, feature selection, model pipelining, and API calling and Flask creation. So first, as I told you, I understood the cardinality of the data, how many data is present for each row. Then after understanding that, I went for data imputation. You can see here how is the data has been imputed, and how different values has been checked for it. Like missing value, you can see so many columns have so many different missing values. Following that, so many different algorithms were found to take the missing value, and after that the best value was found in various processes, and using that then before going for random forest at the end to predict for the whole process. And then the error factor is also shown, how much error factor each is holding, followed by the accuracy factor for each, and then a remark was given whether this is acceptable or not acceptable. So you can see the line industry. We have 9 missing values. It was filled manually. After that, a random forest was done, and during random forest, the accuracy was very low, about 40% error and 37% accuracy. That is not acceptable, so it was removed. Now going forward, understanding why random forests were taken into consideration. When the different algorithms were done to find the missing values, since this is a company data, I didn't go for randomly selecting the mode or mean and filling the dataset, because it would happen to corrupt the dataset or not give proper prediction. I went for the known algorithms and used them for classification and predicting the values. So the relationship type, and I tried all the algorithms that was best suited and was used in the market. I've added everything in the appendix explaining the research papers which have been there, and here I use them. After using them, the most maximum accurate ones is highlighted in green color to represent they are the maximum accuracy got for each value. After filling the missing value, the next step is feature engineering. In feature engineering, we are going to use the data and purify it and make it ready for a data analysis. Now, the encoding, we go for the level encoding. Since some are strings and can't be used because machine learns only binary 0 and 1s, we change it to numbers, and since they're not an ordinal, we use one hot encoding to change it to dummy values and represent in binary format. And then we go for feature engineering. In feature engineering, we look for the outliers and we scale it up so that the outliers are removed, and data is more balanced. We remove the imbalancing of the data set, followed by we take a confusion matrix to check which are the elements that are much more uh, into going in same direction or opposite direction and how they're affecting each other. So you can see that the in the graph below that the enterprise year and your quarter are going the same direction because they are mostly blue, whereas your manager forest forecast status and sales stage name, they're going in opposite direction. Means one if one value is increasing, the other is decreasing. So here from here we can analyze how the data columns are correlated to each other. Then we went for model pipelining. After choosing the best parameter and best algorithms, we made the parameters and we come across this modeling of uh, understanding what are the different models we have made. One model we kept separately for finding out the best parameter for the project, and the other I kept for two. For one for predicting status code using the best algorithm, and the reason for lost or win using the other best algorithm. So total three models are there, and I use Jupyter to represent data in segments and Spider to make the API calls and data analysis. Now going forward for API creation and Flask web representation. Here I have made a dashboard and I have selected the rows that has asked the company, and then I predicted the values for each and got output and represent the status code and the reason behind it as clearly stated. Now understand the prediction models. So how does this start while starting why account type is important? So you can see that this prospect customers and ZA contact are some of the attributes of the type account type, and we can see that there's a good amount of winning in each case. Like a good amount of money is spent for winning, and we can analyze and see that there's a prediction. The good supporters of prediction. There's code is towards status code, means it will help in prediction, and this is due to there's a good customer support and there's a good leadership skill for the company. Then comes relationship type. In relationship type, we see whether the client which is with which the project has been done is a new to the company, new partner, or it's an old partner, is a competitor, or it's a client, or it's a prospect. On the basis of analysis has been done, and estimates on maximum winning in the process of client. So number of wins is much more compared to number of losses, and no sell. It's again to the low leads and good prospect of the company. Then we went for checking the sales stage names, how important it is. So we found that the fifth and sixth stage is winning, mostly winning, whereas the first and second are not that much contributing and coming to no sell. This is the distribution you can see. Then we went for the source type, how the generation of revenue is maximum in which case. The company has numerous amounts of deal like with Google, Amazon, Microsoft, Oracle, but where it went for direct client handling, it has gone maximum revenue. Then the way the manager forecast status is affecting the sales stage name. So you can see here the different stages of sales stage name and manager forecast pie charts. We can see the first one, the commitment is very low, whereas the do not forecast, that means the project has been not completed, and upside means it has been not started also. So like that, if you see the first, second, third, and fourth, they are not that much progressive, whereas fifth and sixth, the people are committed, and the winning and the chances of completing is much more. This shows that the fifth and sixth are much more uh, stages help in predicting is will win compared to others. Now here you see the in the right hand side the primary partners of the company, and the left hand side is the primary competitors of the company. And this has been arranged according to in alphabetical order the companies for your view, and we can see that the uh, best competitor is when the customers are doing themselves. That's the best competitor for the company, because 259 customers have to are doing their work themselves with relying upon Hitachi. So there is the one competition is coming. And the other part, the best partner of the company is Oracle, because Oracle has a lots of projects. Around 130 projects have been supported by Oracle in Hitachi. That's why a lot of progress has been done, because the cloud and the making the different client calls, Oracle softwares have been used. So they were very helpful to the company. Now we go for analysis for the best parameter. The best parameter is came out to be the cell stage name, as it helps to see which are the factors that are affecting, followed by quarter num, that is the quarter in which the project has been done, followed by the manager status for forecast status that represents the as a upside or as a commit, or it will be do not forecast, and you can see the gradual decrease. And the highly correlation between the quarter and enterprise year is clearly stated that they are helping in the prediction of the status code. Okay, now we know which is the best parameter I have taken. I'll show you the steps which I have followed for finding the best parameter. So here is the steps I followed to find the best parameter. So first of all, I went for the all libraries, then I put the data set. After putting the data set, I found which are the characters and which are the numbers. After doing that, I found the uniqueness in each element. After finding the uniqueness is in each row, I further classified it like it's a mixed type, like a quarter, it has a Q4 and there's a year with it, and then there's a continuous data set or discrete or a categorical, and represented them. And after differentiating them, I again checked how many null values are there. And after checking how many null values are there, since I purified the data, you can see there's no null values apart from the reason for lost or found, because that is the one we have to put the values for the missing part. And then as we go forward, we see calculate the number of cardinality, that how many times the data, various datas are there, like types of values are there in each column. Then here you see the outliers in the continuous data set and opportunity, because the sum of the money given to one is compared to very less compared to the other project. So there's overfitting. So and outliers is there, and therefore I use box plot to get rid of the outliers. And then we saw the make a summary and saw the mean, everything about the opportunity level revenue. That's the amount people have paid per year for the projects. And then going forward and making two more columns as a number quarter number part and quarter your which quarter part and which number it belongs to. I have separated them both, and then we made a different column for reason win or lost part. And as we go forward, we did analysis of missing values. Since I have removed missing values, so we can see that it has been purified. And then we go and check the value for how many times a particular attribute repeats itself in a column and what is the weightage. And on the basis of that, I have done a 0.5% minimum value. So I drew a line over here to separate that and represent it. And these values, China, PCAC, GDC, are coming below 0.5%. So I have grouped them into one so that they don't affect the as a like the cardinality and not overfit the other datas. So I went for the analysis, and here you can see I have bunched them and made here a rare value which is not going to affect and increase the cardinality of a column. I did it for all of the data that has been there. Then you can see here that how the array has been come up. Then going forward, understanding the values of the numerical type, how the year-wise number of projects has been done, and the revenue have been given for each one, and in which quarter how the revenue has been generated. Then going forward, we have made the pipeline for analysis of the project. And here I go forward, I remove the spaces and make from here character type, I change it to all numbers for better calculations. Then I change it to encoder to change it to binary numbers for classification. And then I put rare also because to reduce the cardinality. After that, I did the same thing for test data as I did for train data. Then I for gradient boosting, analyzing the various rows and columns. And then I went for analyzing the predicting it and fitting the data. After fitting the data, I found the accuracy in the training set is 92% and in the test set it is 83%. And after reshaping the columns, and this is the how they all are arranged in the descending order. Then we go for the analysis of the programming of how I made the dashboard. So first I went for the analysis of different parts, like I went for the relationship status and checked which of the values are there, followed by I've divided the data in the missing column is for the prediction and training the data for the accuracy, the data train. And then I use the same technique for the rows and columns of both of them. And as I move forward, I found what are the values present in each, and if they're categorical, I made them in a label encoder, followed by adding dummies to them to purify them into 0 and 1s binary format, dropping the columns that are not needed, and thus make the data ready by predicting. And like that, it goes for the each of the rows that were missing. After doing the data refining, I went for analyzing data, how to handle the outliers. So here you can see the outlier has been there in the opportunity level revenue as I showed you before, and how I arrange it without outlier. And then for this is also done for the others, like primary is a primary competitor. So this has been done over here. Then feature scaling, choosing which scale, like min max scaler or for standard scaling. Where min max was more fitting, so I chose that for the rows that are numerical format, so that it doesn't overfit the columns. And after fitting, I added it to the column and then divided the data based on the test and validation testing. After doing validation testing, I found the best parameter was random rainforest. The random rainforest was taken into consideration, and it was found the accuracy and your results. After that, how we handle errors and how we find errors, and that smoothing of the data. After adding smoothing of the data, we found we use random forest to find the accuracy score and predicting its value. And at the end, we use Seaborn to print the outliers and get the values for each of them. Then we went for prediction modeling. We kept it in the model, and then we divided the data based on it has to be there or not, and we tested it and made two models, one train model for status code and one for your reason behind it. After that, we use a min max scanner for one and the standard scaler for the other, depending on the way it is scaling the data. After that, we have encoded the data and we are able to make it a number, and we started predicting on both of them. After predicting, we have got the data status code and your reason for loss or win or loss, and the data is generated, and we got the report for your RMSS value and your value for your accuracy of the data. After that, we go and print, and we go and convert it to words so that we are able to predict it, and we represent it here. Then we go for the API calling. Now API calling we do using Pickle, where we collect your dashboard and use Flask framework in order to represent the output. Here I have grouped them. R for region, G for geography. I gave them a subname, and now I appended the data to each of them and zip it into one file so that it can be handled easily, and sort them in alphabetical order to show the data in a organized manner. After doing that for all columns, I started to call the database and started to read from it. And here you can see I'm requesting from the form. I get the values. If it is there, it will append. Otherwise, it will remove it from the data, depending whether it is selected or not. And at the end, the list will be shown as predicted as output in the pass page. Now going back to the data, okay, I'll show you the dashboard once. So here I have selected the values. I have Southeast Asia, Thailand, TH, here I have country. Here I'm taking the values and represent it to you. Now when I press go, I can see that it will be win, and qualified out, it means it is outstandingly performing and they're winning properly. So this was my project, and going to the PPT, I'll explain you the rest of the findings. So the best parameter was found to be status code, and the best algorithm is found to be random forest. And here I go. Here is the regions that has been affected by the various regions has been affected, like 0 for lost, 1 for your sales, and 2 for win. So you can see the first one is lost. The project has been lost over the years is increasing, where no sell project has been slow, and whereas the win is very less. If only the first in 2020, then it has been mostly no loss or no sale. The vastness you see in the region of 2020 and 2023 in no sale, because the number of projects is very less in that region. Then I explained you this in my Python code and how I found the revenue model, how the revenue is been distributed. Most of the projects are well paid in third and fourth stage. Still they are pushing the projects, but there has been seen a loss and there is no sale compared to a less amount of money has been spent in the fifth and sixth stage, and they are at the verge of completion. Similarly, we can see the distribution for the clients, then a prospect, partner, competitor, and net new in the relationship type. Like it has been uniformly distributed, and losses is always more than your no sell and followed by your wins. But still, the everyone is making a good amount of wins in each part. Then the distribution of the data is not clear because the values has been representing various things in various region. The region represents a part where the project is from. Geography represents the part where the project has been done, and country code is the part where the project has been initiated. So there's a vastness of the project, and the project distribution has been clearly shown over here, like how maximum number of projects are 2018 and 2019 and 2020, and we have and the number of projects will be taken is very less. 2021 and 2020 and 23 are 2 projects only. Now coming to the winning part, the maximum winning is in the Southeast Asia, where all the projects has been won. It is in the fifth and sixth stage, and it is committed in the forecast, and it is 2020 is a successful year for them. Followed by, this is the area where the successful is there. Thailand has maximum success, followed by Singapore, Malaysia, and India. Then year 2021, we see there are only 336 projects, and most therefore no sell or lost. In the revenue, you can see the amount of revenue for at the sum of the projects, followed by stages, various stages has been followed, and how the distribution has been done. Then in 2020, there are only two projects. Both are no sales. First one is no sell, and because it's a new customer and it's only in the second stage, therefore the manager is not ready to forecast the project right now. The sum is huge, and there's no primary partner to support the project. The second one is also more or less similar, but here is in the first stage, and it's a digital project which is highly costly, but there's not enough budget to do the project. Now, year 2023, there are two projects, both are no sales. The first one is a new customer, and it's the first stage. Again, the manager is not ready to forecast it because it has been not ready. The amount is also huge. There's no primary partner to support the project. There's an interesting fact in the second part. Although it's a prospect, and we know the prospects are the maximum amount of winning they have made in the account type, the customer is not ready, and there is a primary partner which is Oracle, and the project is Oracle based, and so therefore, as we know, maximum amount of work can be done by Oracle itself. Plus, Accenture is also having a competitor to this project, so therefore, there's a no sell comes to this project also. So uh, now there's some questions, some interesting questions that comes up how it can be integrated to new data. So I showed you the pipeline where the data is taken and how it will be processed and been purified and kept. The data you can just put it into that, and we can purify it. So that's one approach. The other approach is we can put a questionnaire and the tables which have been selected. We can put those data from the data set, and the data rest of them will be handled by the model. Apart from that, the we get all the data set from the data, and then purify it and bring it down to this process. Then what things we can take care of as a student, this might not be my reach right now, but as a data science student, whatever I understood from the data, I can say it that the projects which are in the first, second, or third stages are not that much ready for the prediction, or they're not like there's a huge amount of money they're given to them, but they have not been pushed, so they should be taken care of. They should be forecasted by the manager, and these are the things. And then there should be analysis of relationship type, and there's a negotiation between the should be done between the partners so that more opportunities can be found. And analysis has been done that it has been seen that although there is a much more amount of we have good connections with the partners and very less projects that have been affected by your competitors, then also the competitors are very strong. We should keep in mind how can we make it better. We have to make better connectivity of the project so that new data more robust it can be. And this is the how we can deal with it. And the data such as the owner name, the dates which are changing every time, which can get corrupted, we should keep them separately, and the filling up data that we can keep it separately in two separate databases. The problems that I faced while doing these projects are here, and there's a API calling and connection, the backend and frontend connection. Then there was a connection missing, asynchronous connection is missing, like connecting to database and coming out with the predictions. And sometimes there was no clarity, was there not there for predicting why it is a loss, although it is in the coming found to be in one of the popular winning regions. These are some improvements are required. Then there's a correlation between the elements has to be much more cleaner, because some of the elements are showing to be like in opposite direction, but when practically using they come out to be in the same direction, like helping in the prediction. These are some of the this can be because of the missing values or so the corruptness of the data. Thank you.